Okay, for this lesson you are going to need your calculator, and it's very easy if you do have your calculator for most of this today. Okay, a logarithm that has a special base of 10 is called a common logarithm. I'm going to put common log. A logarithm to the base e is a natural logarithm. E is just a button in your calculator. It is a value, but if you see a logarithm with the base e, it's called a natural log. And if you see a logarithm with the base 10, which actually a lot of times they won't show it at all, it's a common logarithm. It says, just like it says in the next line, when the base is 10, the base does not need to be written as a subscript of the word logarithm. So if you see something like y equals log x and there's no base on it, notice there's no little subscript here. If there's no little subscript there, you assume it's a 10. The natural logarithm, I said it's with a logarithm with a base e. We don't normally write it like that. We write it as y equals ln x for natural log. And you have the log and the natural log button in your calculator. On the left-hand side, in my calculator it's black, but yours might be different. But the left-hand side by the 4 and the 7 key, you'll see the log and the ln button. And what you're going to do is actually use your calculator right now. It says find the common and natural log of each number to the nearest 10th. Well, what you're going to do is you're going to type in your calculator right now, log of 3.75. When you type log 3.75 to the nearest hundredth, you should be getting 0.57. And then you're going to type ln of 3.75, which is 1.32. I'm going to skip the next two. You can do those on your own. It's easy enough. Then you're going to the fourth one. It's an e. You're going to type log and then e. The e is going to be the second ln button. If it asks you for power, please put the first power on it. You know you did it correctly if you get 0.43 as an answer. And then now type ln e. Same way, you'll type ln and then second ln. If necessary, put the first power on it. And you should see it equals 1. This concept right here will be very important in the future. ln e always equals 1. And that's going to actually help us solve equations later. Next part, evaluate each log to the nearest hundredth. Again, this is just typing in the calculator. So if you type log 0.002 in your calculator, you get negative 2.70. Log 64 minus log 16. Yes, you can type it in your calculator. Let me show you just practice from yesterday's stuff. If I want to condense it to one logarithm, subtraction condenses to a division. 64 divided by 16 is 4. Now, whether you type the first one or the second one in your calculator, you should get the same answer. You get 0.60. I'm going to have you guys try the other three. Again, it's all calculated work. That shouldn't be too difficult for you at this point. Next part, for each given logarithm, find the anti-logarithm x. Write your answer to 4 decimal places. Well, for this one, it's really just saying solve for x. And we've done ones like it for the first two anyway. To solve this first one, we use base. Notice they don't give you the b on the base, so we know it's a 10. The exponent is 0.5787 equals x. Well, when you type 10 to the 0.5787 in your calculator, you get 3.7905, and I am doing 4 decimal places. I'll leave the second one for you. All right, the third one, the ln. When you want to get rid of an ln instead of a logarithm, we don't use base anymore. We use e. Okay? And how you show your work is you do e to the ln x will equal e to the 0.5787 power. E and ln cancel each other out on this left-hand side, so you're left with an x. And then you can type e to that power. And again, the way you do that is by second ln. When it asks for a power, you put 0.5787. and you get 1.7837. Let's try on the next one here. We'll do e to both sides. You'll get x equals, and e to that power is 123.9651. I'm going to leave that last ln1 for you to practice. So at this point for the do now, you can do the problems that I have skipped. It should not take you too long.